Hi guys, welcome to Worms Maths Academy. This is 2017 Methods Exam 1 from the Northern Hemisphere, hence why it says 6th of June. Okay, this feels like it was a while ago, but obviously it wasn't. First question, we've got a product rule question. You must show working for 2 marks. So here I'm just going to say let u equal e to the 2x v equals cos x on 2, u dash is 2e to the 2x, our derivative. When we derive cos, we get negative sign, so we get negative a half sine x on 2. So dy dx is the product rule. So v times u dash and u times v dash. So I'm going to say 2e to the 2x cos x on 2 minus a half, because I've got that half here, e to the 2x sine x on 2. I'll leave it like that. Okay, f of x equals log e sine x. When we derive a log, it's the derivative of the top, which is cos x, over sine x. So it's the derivative of the bracket over the bracket itself, and that's 1 on tan x. I mean, I'd probably just leave it like that if I was you. Special students would know that it's cot x, but don't worry about it. So f dash of x, f dash of pi on 3 is equal to 1, 2, root 3, pi on 3, cos of pi on 3 is a half, over sine of pi on 3 is root 3 on 2, so it's 1 on root 3, or root 3 on 3. I'm sure either of them would be acceptable unless it said to do it using the giving rational denominators. Okay, find an antiderivative of cos 1 minus x dx. So when we integrate cos, we get sine, but we've got to divide by the negative 1. So negative sine 1 minus x. We don't have to put a plus c because it's just, it says an antiderivative. So you can leave it as negative sine 1 minus x. Evaluate that. So the first thing I would do, 1 to 2, 3x squared plus 4, why did I do that? 4x to the negative 2 dx, which is 2, 1. Okay, if I add 1 to that, I get 3, and I divide by 3, so I'm going to get x cubed. If I add 1 to that, I get negative 1, so I'm going to get negative 4x to the negative 1, which is 4 on x. Of course, when we substitute in 2, we're going to get 8 minus 2, minus, substituting 1 minus 4. So we've got 6 minus 3, which is 9. We won't say square units because we don't know if it's an area. Well, it is an area, but it's a signed area, so it includes negatives. Okay, f of x. F of 4 is 25, so that means when we f of x is the integral of 3 on 8 x squared minus 10x to the negative a half plus 1 dx. Okay, when I integrate that, when I divide by 3, I'm going to get 3 on 3 times 8, which is just 1 on 8 x to the 3. Okay, if I add 1 to that, and I divide by If I add 1 to it, I get a half. If I divide by a half, it's the same as timing by 2. So I get now 20 root x, and then I get plus x plus c. And we know f of 4 equals 25. So we're going to get 25 equals 1 on 8 times 64, because 4 cubed is 64, minus 20 times the square root of 4, which is 2, plus 4 plus c. Therefore, c is equal to, that's 8 minus 40 is minus 32, plus 4 is minus 28. Bring it to the other side, it's plus 28. So c, oops, I just did it again, equals 53. So therefore, f of x is 1 on 8 x cubed minus 20 root x plus x plus 53. Okay, state the smallest possible value of k such that x equals 3 pi and 4 is a solution of tan x equals cos kx. Okay, so tan of 3 pi on 4 is equal to cos of 3 pi k on 4. Tan of 3 pi on 4, it's in the second quadrant, so it's negative 1, is equal to cos of 3 pi k on 4. Cos inverse of negative when does cos first equal negative 1? When it's pi. So 3 pi k on 4 is equal to, pi. Okay, when we divide that to the side, we're going to get k is equal to 4 on 3. So the smallest possible positive value of k such that x equals 3 pi and 4 is a solution of tan x equals cos kx. Okay, 2 sine squared x plus 3 sine x minus 2 equals 0. So first, let a equal sine x. 2a squared plus 3a minus 2 is 0. 2a, a. We want to end up with a 3 in the middle. Plus 3. So plus 2 minus 1 is 4. So a equals 1/2, or a equals negative 2. Therefore, sine x is equal to 1/2. Sine x is equal to negative 2. No solution here, as sine's only between negative 1 and 1. Sine x equals 1/2, 1, 2, root 3. So my angle's pi on 6, so therefore x is equal to pi on 6. And then we also want that angle in the second quadrant, which is 5 pi on 6, because it's pi minus pi on 6. So they are our solutions. Okay, tan 2x between negative pi on 2 and pi on 2. Okay, my period's pi on 2. So that means my asymptotes are at pi on 4. Don't forget to label them. They are equations. Stop your stupid thing. Okay, usually it would intersect at the halfway mark. However, it's been translated up one, so it's going to go through there. There's no dilation factor, so if we move across the halfway mark, it's got to go through 2. And it's got to go through negative pi on 8, 0. what it's going to look like. Label the endpoints axis-intercepts for their coordinates. So there's your axis-intercept. Okay, over here, that's going to be pi on 2, 1. That's going to be pi on 8, 2 pi on 8, 3 pi on 8, 0. It's going to look like that. That's going to be negative pi on 2, 1. Then it's going to get up. Okay, label any asymptotes, done. Label the endpoints, done. Label any axis-intercepts with their coordinates, done. Okay, looks good. Use features of the graph to find the average value of that between negative pi on 8 and pi on 8. So negative pi on 8, so from here to here, okay, that area in there and that area in there are going to cancel each other out. So the average value is just going to be 1. Nice and easy. Okay. Records for the arrival times of train at a busy train station. Having kept for a long period, the random variable x represents the number of minutes after the scheduled time that the train arrives. At the station, that is the lateness of the train. Assume that the lateness of one train arriving on the station is independent of the other one. Find the value of p. Oh, that's a tricky one. 0.1 plus 0.4. Oh, actually, we're just going to... They add up to 0.8, so p has to equal 0.2. My expected value, e of x, 1 mark. So we get negative 0.1 plus 0.3 plus 0.4. Of course, I'm just multiplying those together and then adding them, which is 0.6. Okay, find the variance of x. So I've got to find e of x squared. So if we square that value, we get 1, times it by that 0.1, we get 0.1, plus square 0 times 0.4, you get nothing. 1 squared times 0.3 is 0.3. 2 squared is 4 times 0.2 is 0.8, which gives me 1.2. The variance of x is e of x squared. It's also 3 on 5. E of x squared, which is 6 on 5, that's the same as that, minus e of x all squared, 3 on 5 squared. That's going to be on 25, so put this on 25, so 30 on 25 minus 9 on 25, which is 21 on 25. Is that right? Looks good to me. A passenger catches a train at this station on 5 separate occasions. What's the probability that the train arrives before the scheduled time on exactly 4 out of these 5 cases? So the probability that it arrives before the scheduled time is this, 0.1. So we can say x is binomially distributed. Oh, is that x? Let's say something different. T is binomially distributed 5 times, and exactly 4. So I want the probability that t is equal to 4, which is 5 choose 4, 1 on 10 to the 4, 1 on 9 on 10 to the power of 1. Okay, 5 choose 1 is 5, 5 choose 4 is 5, so 5 times 1 on 3, 4, times 9 on 10, which is, can divide that and that, we get a 2, so 9 on 20,000, so t equals 4 is 9 on 20,000, so that's the chance that the train arrives before on exactly 4 of those occasions. Okay. A large sporting arena. There are a number of food outlets, including a cafe. The cafe employs 5 men, 4 women. 4 of these people are rostered on at random. Let P hat represent the same proportion of men are rostered on a particular day. List the possible values P hat can take. So, P hat could be proportion of men. There's 4 women and 4 are chosen. So we could have no men. We could have 1 on 4, 2 on 4, 3 on 4, or all men. Okay, find the probability that P hat is equal to 0. So no men. Probability P hat means that they're all women. Okay, so the first person, we've got 4 women to choose from out of 9. Then we've got 3 out of 8. Then we've got 2 out of 7. And then 1 out of 6. They'll cancel. That'll be a 2. That'll be a 1. So we get 1 on 9 sevens are 63 times 2 is 126. We could have also used hypergeometric distribution, which would be men. How many men is there? 5. Choose none. 4 women. Choose all 4. Over 9 choose 4. 5 choose none is 1. 4 choose 4 is 1. So they're both 1. 9 choose 4. 9 factorial. 5 factorial, 4 factorial. Let's just write it out. 9 by 5. Bloody hell. 8 by 7 by 6 by 5 factorial. On 5 factorial, 4 by 3 by 2 by 1. They cancel. They cancel. That gives it a 2, so I get 126. Either way, you get the same answer. Whatever floats your boat, so 1 on 126. There are over 80,000 spectators at the sporting match arena. 5 in 9 of these spectators support the Goannas team. So let's say P is 5 in 9. A random sample of 2,000 spectators is selected. So N is 2,000. What is the standard deviation of the distribution of P hat, the same proportion of spectators? So the standard deviation of P hat, that's the square root of 5 on 9 times 4 on 9 divided by 2,000. Okay, I'm going to write this as the square root of 20 on 81 divided by 2,000, which is times 1 on divided by 2,000. So cop that off. I'm going to have a 1. So I'm going to have 1 on 8100 square rooted. The square root of 1 is 1. That's going to be 90 times 90, 81, 1, 2. So it's going to be 1 on 90. So the standard deviation of P hat is 1 on 90. Assuming I didn't stuff anything up. this looks fun. G of f of x. G of f of x. So G of f of x, I just said that like 4 times. So 4 minus 2, 2x cubed plus 1. 4 minus 2 is 2 minus 4x cubed. F of g of x, and express it in the form f of g of x, f of g of x. So f of g of x is 2, 4 minus 2x cubed plus 1. Okay, we've got to express it in that form. So I'm thinking, because there's no coefficient here, I've got to take out a negative 2. If I take out a negative 2, that's going to become x minus 2 cubed. But when I take that negative 2 out, I've got to cube it. Negative 2 cubed, negative 2 times is negative 8. And when I times it by the 2, I get negative 16. And that 1, I'm going to put it out the front. So I get 1, 16, x, 1 minus 16, x minus 2 squared. Okay, so so the transformation maps the graph of y equals g of f of x onto the graph of f of g of x. So g of f of x, that becomes this. That means we've got no y dilation. So first thing, we've got to dilate it from the x-axis. So if we dilated, if we want to make 4 become 16, dilated 4 from x-axis, so that would become 8 minus 16x cubed. And we want to move it 2 to the right, translated right 2. So that would be B would be 2 to the right. So that means A is 4, B is 2, because we want to move it 2 to the right, because it is negative 2. So we replace x with x minus 2. So that would be 8 minus 16, x minus 2 cubed. And then that's 8, so we want to translate it down 7. So that would give me 1 minus 16, x minus 2 cubed. So c equals minus 7. So a is 4, b is 2, c is negative 7. How many questions is this? Oh, it's a nice short exam. Have we done them all? Okay, the function for rule f is given by, this is worth a few marks. Function by rule is given by that way. Find the domain and rule of the inverse function. Okay, so let f of x equal y, swap x and y. So we get x equals root 2y plus 3 minus 1, root 2y plus 3 is equal to x plus 1. 2y plus 3 is equal to x plus 1 squared. Y is equal to 1/2 x plus 1 squared minus 3, f inverse of x. Let's just do a half x plus 1 squared minus 3 on 2. What's the range of this function? It's been translated 2x plus 3 equals 0. So x equals negative 3 on 2. And it's been moved down 1. So my range is negative 1 to infinity. So here, domain is x is greater than or equal to negative 1. And could say, don't forget that's f inverse. Okay, x is an element of negative 1 to infinity. Okay, solve f of x is equal to f inverse of x. So if you think about it, we've got one graph like that, one graph like that. So they're only going to intersect on the line y equals x. 2x minus 3 minus 1 is equal to x. Root 2x minus 3 is equal to x plus 1. 2x minus 3. Now this x plus 1 has to be greater than or equal to 0, because if I square root a number, it's got to be positive, which means this under here, that's got to be positive, can't be negative. But anyway, so move on. That's a 3 is equal to x plus 1 squared. X squared plus 2x plus 1 is equal to 2x minus 3. X squared um, 0x plus 4 is equal to 0. What have I stuffed up? It's 2x plus 3 plus that's a minus 2. Like, that doesn't work unless you do spash. Therefore, x is plus or minus root 2. However, x is greater than or equal to negative 1. Negative root 2 is less than negative 1. Therefore, x is equal to root 2 is the only solution. Did it ask for the coordinates or just not? Okay. Root 2x plus c minus 1, where d is the maximal domain of G and c is a real number. What values of that have no real solutions? Okay, if we do the same thing as before, 2x plus 1, c minus 1, because it's a square root graph, we know it's 1 to 1. So, and we know it's going to intersect on the line y equals x. Okay, so root 2x plus c is equal to x plus 1. 2x plus c, once again, x has to be greater than or equal to negative 1. That equals x plus 1 squared. 2x plus c is equal to x squared plus 2x plus 1. So x squared, those two x's are going to cancel again. Plus 1 minus c equals 0. So our discriminant has to be less than 0. So in this case here, b squared, which is 0, minus 4 times 1 times 1 minus c has to be less than 0. So negative 4 plus 4c has to be less than 0. 4c has to be less than 4. C has to be less than 1. So as long as c is less than 1, we'll have no real solutions. If c is equal to 1, we're going to have one real solution. So we know if c equals 1, we have one real solution, because if we let that equal 0, then we would get c is equal to 1. For what values of c does g of x equal g inverse of x have exactly one real solution? So c equals 1, but it's worth 2 marks, so it's got to be something else. Okay, so what's our domain of that function? Let's work it out down here. 2x plus c has to be greater than or equal to 0. So x has to be greater than or equal to negative c on 2. So domain and range, lots of g, so greater than or equal to negative c on 2. My range, negative 1 to infinity. So g inverse is going to be negative 1 to infinity. And my range is going to be negative c on 2 to infinity. So if c equals 1, they have one real solution. If c is less than 1, we have no solutions. So if c is greater than 1, if I said c was equal to a 3 on 2, which is greater than that, it's greater than 1, okay, let's do a quick sketch. So g is negative c on 2, so if we let c equal 1, we're going to get g is negative c on 2, which is negative a half. Just going to make it bigger, negative a half. And then that's going to go from, shouldn't have done that. So negative a half, negative 1, negative a half, negative 1. Okay, so if our domain here is negative a half and our range is negative 1, so negative a half, negative 1. If we let x equals 0 and c is 1, we get 0, so it's going to go through there. So that's going to look like that. And then our other graph is going to be negative a half, 1. So that's why they just touch there. Okay, as I increase c, that value, c, if I let c equal 2, I would get negative 1, negative 1, and I would get negative 1, negative 1. So they're going to look like that and like that. Anything in between, I would have had 2 intersection points, because slowly it's moving out. Here I've still got 2 intersection points, but then as c gets bigger, like if I made c equal 4, that would be negative 2 and negative 1, and the other one would have been negative 1 and negative 2, so we're not going to have any intersection points. So when it's equal to 2, we've got 2 intersection points. But as it gets larger, we're not going to have any more intersection points. So c equals 1, we're going to have one solution, and c, we want one solution, is greater than 2. Because they'll only intersect once on that line. So as they're in, they intersect twice, but then as they get out to this point 2, that's when they still intersect twice, but any further, and they're not going to touch each other anymore. Cool. So that's our answer. C is equal to 1. We have one solution, and C is greater than 2. We only have one solution. Notice it says values. Okay, I think that's it for Exam 1, 2017, Northern Hem. Good luck on this year's exam if you're using this as revision. Bye.